Just before we get started, I wanted to introduce myself a little bit. My name is Koen Patel. I'm a solutions engineer here at CloverDX. I help out mostly on the sales side of things, making sure that demonstrations go well, that you understand the product pretty well, and help out with any scoping or any proof of concepts that might need to be done. With that being said, we'll be going over best practices for teamwork across the data project lifecycle. Before we get started, I wanted to kind of highlight what the goal of the webinar will be. So data integration pipelines, like all software systems, have a life cycle, and without understanding it, it can be difficult to manage your environment from the various parts of development, right? From development to testing and all the way up to production. Additionally, it can be challenging to collaborate with other team members. So we'll be going over in this webinar a high-level overview of CloverDX's architecture, as we'll be referring to this throughout the presentation. Additionally, we'll also go over how to manage your various environments and share data between them, and how to share data between team members. And then we'll go over some of the details of the environment and get into what it looks like within Clover. With that being said, I wanted to start off with a high-level overview of CloverDX data management platform, since we'll be referring to this throughout the webinar. So as you can see from the slide here, our data management platform is made up of two major pieces of software. They work hand in hand to help you create software development lifecycle for your various data projects. The first one is going to be CloverDX Designer, which you can see on the left there in the green. This is a full IDE for the CloverDX platform. It allows you to sort of prototype and build your jobs in a visual way. It can then be used to easily test and debug your data pipelines. And Designer has full support of version control, which allows you to easily share projects between users. And Designer can deploy those various data jobs that you create directly into CloverDX server. Now, once server has those deployed projects, it is the enterprise runtime that provides automation, orchestration, and monitoring capabilities for the platform. It can be deployed in a wide range of systems, whether that's in the cloud, on-premise, in different operating systems, containerized or in virtual machines. Really doesn't matter. You can run it anywhere. That makes it easy for our customers to fit it into their existing infrastructure, so that way you don't have to change or tailor your infrastructure around this piece of software. Also important to note that CloverDX can process a wide range of data formats in different styles. You can work with data in batches or in more real-time fashion with messaging, APIs, or even streaming. You can also work with data in any format, starting with structured data all the way to complex hierarchical formats. And CloverDX allows you to implement complex data transformations and orchestration pipelines with ease in a nice visual fashion. As a platform, CloverDX is very flexible and can be deployed in a wide range of environments. So no issues there. Virtual machines or directly on physical hardware, doesn't really matter. The last thing I wanted to highlight is just the scalability. Oh, sorry about that. Last thing I wanted to highlight is just the scalability. You can scale by adding additional cores. You can also scale horizontally by adding additional nodes. So that way you can have a highly available sort of runtime in production at all times. Now that we have a little background on CloverDX data management platform and what it's capable of, let's talk about the first and probably one of the most important aspects of working in a successful data project lifecycle, and that's going to be teamwork. So a lot of organizations have one or more teams. Amongst these teams are various employees, each with their own roles and responsibilities. To manage them in a company, you likely would already want to use some sort of existing infrastructure. That could be something like Active Directory or single sign-on or a SAML. environment. And ideally, the tool that you use for your data project will be able to leverage that existing infrastructure. Now, what's so important about having team member roles? Well, I'm sure all of you guys have heard of the various data hacks and issues that have popped up for companies that make the news. So roles is one tool used to minimize the chances and also minimize the fallout if these hacks do occur. It can also keep data as private as possible when you're dealing with personally identifiable information. You want to make sure that only those that absolutely need to see the data can actually see it, and those that might not need to see the data can avoid seeing it. And then finally, it can also just help prevent mistakes. Those mistakes can be costly, or they can even be minor, but just little headaches for your employees. So it can help you prevent mistakes by making sure that the employees that you give access to the various parts of the tool are properly trained and they have access because they need it and they're regularly using it instead of just having full access to the entire software, especially on parts that they haven't been trained on. So how are roles and users handled within CloverDX? Well, we allow you to create users and roles within the platform. We recommend using your existing infrastructure. So if you do have like an Active Directory environment, you can leverage that, but we don't necessarily require you to do so. Regardless of how, if you want to set up groups directly in Clover or using existing infrastructure, you have the ability to create groups and define permissions with those groups in Clover. So once you create a group, you can get pretty granular with the permissions that you assign to that group. And then once you assign those various permissions, you can actually assign users into those groups. That way, the users that have access to those groups have access to all the permissions of that group and only those permissions, not anything else additionally. So let's take a look at what this all looks like in an example organization. So here you can see that we have a medium-sized organization with a test and dev environment, along with a production environment on the right. So you can see here that we have a couple of different users here. Developers, you can see on the top left. Obviously, the developers would need to have, if not full, nearly full access to CloverDX Designer and Server in the test and dev environments. And then they would also probably have access to a limited set of permissions in version control. If you have a version control tool, that's great. Otherwise, you can push these directly into the production environment via the design interface. So there's no issue there if you don't have existing version control or something like that in place. But those developers would be allowed to push some changes from the test and dev environment into the production environment. Then on the production side, you have obviously your support team that would be able to analyze and make sure that the production environment is running well. They would have nearly full access to CloverDX server, so that way they can see what's been running, what the status is, maybe rerun certain processes if needed. And then they would have perhaps some access to CloverDX Designer just to take a look at the underlying code and the pipelines that are pushing the data into their production environment. Of course, in production, you may also have business users, and those business users would likely have limited access to server as well. And they could use this access to ensure that data jobs that they care about particularly ran successfully, or maybe even run reports and pull out data from your data environment. Now, in larger organizations, you might have a little additional layer or two of environments, right? So you might have a separated dev and QA environment. That way that you have additional checks before any code changes make it all the way to production. And then beyond that, right, you probably would likely have version control running through all of these systems or all of these environments, I should say. And on the production side, you might have a similar situation with support, obviously supporting your infrastructure on the production side. But what's interesting is that you might have not just business users, but you might also have a more generic end user. Those end users, especially with larger organizations, could be a part of your organization, or they can even be a part of other organizations. They could be, you could think of them as customers or partners that have limited access to servers so that they can interact with it in specific ways. Those specific access points could be API endpoints. That way their business systems can talk to your company's business systems and transfer data that way. Or it could be web forms to upload and download data within your data environment. They would be able to run reports and know what's going on with the data environment, and particularly whether or not their data environment is working as expected, and if metrics come back as they'd expect. So it's interesting that you can get so granular with the permissions that you can actually allow access to the server environment to even third-party end users, which we have a few examples of. Now that we have an overview of what the life cycle looks like from development to production, I wanted to take a little bit of a deeper dive into the production side of things. So just as a reminder, CloverDX data management platform has two major pieces. That's Designer and Server. They work well together so that any changes you make in Designer can be pushed to Server. But how you push it into Server is completely up to you. Some choose to push changes directly from Designer into Server using the user interface. Others simply get the latest version of the project from a repository and push the changes to Server manually. And finally, we even have other users that use continuous integration tools like Jenkins to automatically push any changes into production. Regardless of how you push those changes into your production environment, it's important to note that pushing those changes in Clover is very easy and doesn't require compiling of any code, so it's very quick as well. So now would probably be a good time to talk a little bit about version control and how it relates to CloverDX. So version control is a system that allows you to keep track of changes. As you make changes to a file, you can go back to previous versions. It also allows you to branch off and create new lineages of files. So what issue does this actually solve? Well, it allows you to make changes to new test development with a safety net of being able to go back to the stable version. You can think of it as like a super powered undo button for the end user. And with this version control tools, you would get a couple of advantages, right? And the biggest one is probably going to be collaborating with others. So you have the ability to go back to any previous versions, which is great, but it also allows you to ensure effective collaboration on a single project. As projects get larger, you add more and more individuals and teams to it. You could run into the risk of users overwriting changes from other users, right? So you might save the latest version thinking that you have all the changes made by another team, but perhaps your version does not have all of those changes. So you have the ability to sort of take a look at what changes were made by various people and ensure that the latest version of your test data pipeline or production data pipeline has all of the changes that you're looking from the various teams. Also, it gives you a nice little safety net as well, right? So you can determine differences between two different versions, and if things go badly, you can undo all of the current changes and go back to previous known working versions, which is a great feature. So what does this look like in CloverDX? Well, you can use any version control with CloverDX. We don't limit you in that way, but we do include a Git client since it's the most popular one across our user base. And then Clover also doesn't force you into a specific strategy. So there's no specific strategy for branching or tags or how changes are pushed. All of that is completely up to you and the team. And Clover also allows you to automate the process as well. There are various data pipelines that you might want to automate, and Clover allows you to do that via API calls. So that way you can automatically download the latest and greatest versions and push those into your production environment at any point. So what does this look like in more of a production environment? And what does it look like whenever you add DevOps and DataOps into it? Well, version control, you can version control all of your projects and artifacts with whatever client that you'd like. So as I mentioned, Git client ships directly with Designer, but you can also add other version control systems available via the Eclipse marketplace. So what's interesting is that you can also include infrastructure as code with this as well for more of a DevOps environment. So you have the ability to work with Kubernetes and Docker containers, and you can work with cloud deployment vendors as well. So AWS CloudFormation, Azure ARM are also compatible. And you can see down there at the bottom what this might look like, right? So you have at the bottom left there, you can see the users. They're interacting either with version control or CloverDX Designer. And version control and CloverDX Designer are sort of synced. So you can, any changes you make in your version control system can be pushed to Designer, and vice versa. Any changes you make in your Designer can be pushed to version control. Then you can use, then you have a couple of different options, right, of how you want to get the data into server. You could push those directly from your design environment into your production environment or into your server environment directly, as you can see on the top right with the dashed green line. Or you can add an additional layer. You can add a continuous integration tool like Jenkins, for example. Jenkins can clone any changes you make into your version control system and then deploy that via API calls to the server. So it can clone whatever's in your repository and then push those into server, make sure that all the files and all the artifacts that you need for your data project are pushed to server, and then any automation or alerting is also pushed into server. So just to highlight how this works in a more real-world use case, we have a couple of examples here, iptiQ and Limos. So you can see here that both these companies use CloverDX and use version control within CloverDX to manage their data environment. First, I'll talk about iptiQ and what they do and what that looks like, right? So iptiQ uses CloverDX to basically just load data from their insurance platform into an Azure data warehouse. The way that iptiQ handles their version control use case is that they store everything in a Git repository. Once they're ready to make any changes to their production environment, they actually pull the latest and greatest version of their pipelines from Git and use ARM, or Azure Resource Manager, to create and manage CloverDX instances. Azure Resource Manager allows them to spin up new environments and decommission old environments, refresh their environments, scale up their environments, right? So you can add all of these settings into ARM and basically be able to create and deploy CloverDX server instances on the fly, depending on what the use case is. Their projects are in Git, as I mentioned, and they use Azure Data Pipeline to download the latest and greatest version of the actual code that they want to execute in their various CloverDX instance servers. So between the projects that are being run, being in the Git repository, and the infrastructure being in the Git repository, essentially everything that they need to spin up and create a new environment and all of the logic that they want to run on that environment is stored in the Git repository. And they can, as a part of their development process, reload that configuration or run jobs as needed during their deployment. That makes it very easy for them to make changes and scale up or scale down their solution to meet their demand needs. Additionally, we also have Limos. That's the London Insurance Marketplace Operation and Strategic Sourcing. bit of a mouthful there. But they essentially use CloverDX for data migrations and to serve up a variety of APIs on top of their data to their customers. So they run CloverDX in a Dockerized fashion. So they use Docker files that are hosted in GitHub. And for deployment, they use GitHub Actions to create new instances and also deploy the latest version of their code from the Git repository to a newly created CloverDX server instance. So very similar in what they do, right? They have GitHub that stores their code for what they want to run and also their environment details. And they're able to sort of automate that using GitHub Actions. So both of these companies store this essentially the same information. They just store it in different places and use different tools to deploy that code into production. Regardless, though, CloverDX server can support, or CloverDX data management platform in general, I should say, can support both of these instances. All right, now that we talked a little bit about the development side of things, I wanted to talk to you about a little bit of an issue, which is for some of our clients, which is data quality. So data quality can be an issue and that you have to deal with any business. And that's especially important when you're dealing with large volumes of data. We've all heard the term garbage in, garbage out. And that's especially true when dealing with traditional coding as it has strict requirements. So it's important to check your data as early as possible, especially since there's no need to waste time processing or even costs if you're in the cloud, if it's just going to fail downstream. But this could mean multiple checks in a single data pipeline. As you bring additional data sources or use code to manipulate the data, you might want to run additional checks at that time as well. Beyond that, it's important to think about the actions. Once you do identify the issues that you're looking for or issues that pop up, what actions do you take, right? So do you stop processing all data or do you siphon off the bad data and process the good data? If you do siphon off the bad data, what do you do with it? At a minimum, you should probably notify the appropriate people to correct the bad data. On the other hand, you may even be able to correct some of the errors automatically with updated logic in your code or your data environment. So what does this look like in Clover? Well, Clover is very flexible and can identify the bad the bad data in mainly two features, what we call components. They are the validator and the profiler probe. The profiler probe takes a look at all the records and ensures the entire data load meets your quality standards. So if not, you can reject the entire data load. Validator, on the other hand, allows you to create rules for what the data should look like. And if any of the records don't match those rules, they're pulled from the normal data workflow and pulled into a separate workflow. Once these records are siphoned off, they can be handled as a completely separate workflow with updated logic, with new processing. So that way you can try to, at the very least, create a report that's meaningful and actionable and easy to use, and maybe email it off to the appropriate end users. Or it could even additionally mean running advanced logic that tries to correct the errors and replace the corrected error records. So here you can see an example of how we handle CloverDX or how we handle data quality in CloverDX. The initial validation components are in purple. So you can see the profiler, probe, and validator and business rules there are in purple. And if you look at the record count validation, this is where we're actually taking a look at the data as a whole. And we are looking for at how many records are being processed, the null counts for certain fields, maybe the averages for other fields, or how many specific values do we see in certain fields, etc. So you can set up Profiler to take a look at all of these things. And when validating, we are just checking to make sure that the overall statistics match our expectations. And if not, we simply, and if they do, we simply record the relevant statistics into our auditing database along the top there. And if it has too many issues or nulls and doesn't match our criteria, then we actually fail the entire data load. Beyond that, you can also see that we're running business rules validation underneath that. There you can see that we're using validator and calling it business rules essentially to ensure that our business rules are met. And these, as you can imagine, are very specific to each use case, to each data workflow, to each company. And if the records pass the validation, great. We mark them as successful. And if not, then we create a few data reports to record those issues so that they can be looked at and addressed by whoever needs to address those. And just to really drive home the point, I wanted to talk to you about a couple of use cases that we have. So the first one is LF Logistics. They have a very specific problem dealing with address information. They deal with Asian addresses and from various countries, right? So that could be Asia, that could be China, that could be Korea, that could be Japan, that could be Malaysia. There's so many different complexities there with each having their own set of characters, their own formatting within the country, and let alone the differences between each country, right? So the addresses oftentimes are also very low quality as they are often scanned from an image. So they had a team of just 30 people that were having a lot of trouble scaling up the operations. With such a limited number of resources, they couldn't check all of the addresses that had issues, and there were plenty of them that did have issues. So what they did is they leveraged CloverDX to create a rules framework. Each set of rules was tailored to country-specific address structures. Each had their own validation rules and legal restrictions using this automated infrastructure. They were also able to easily modify those rules and provide additional supported countries whenever those countries were open for business. And all of that did not require expensive coding. End users or business users could essentially create those rules using the rules engine without actually getting developers involved. That's great for being able to scale up and add additional workflows to the data pipeline. But it went a little step beyond that, right? So workflows that involve making changes to addresses that couldn't pass validation, they were able to create workflows that allowed them to easily make changes to those addresses. Users even had the ability to drop a pin on a map to give coordinates to the delivery driver if they couldn't resolve that address more granularly than that. But the framework not only made scaling and fixing those issues better, but also improved over time. So as new rules came in, they could be added quickly and done so without development help. But more importantly, any fixes that they made to addresses would be captured and remembered and then leveraged for the next time the same address is seen again. So that way, if they made a correction to one address, they would be able to make that same correction going forward and not have any intervention involved at all. This over time reduced their errors by over 90%. So that way they could focus more on growing the business and handling customer support instead of just handling address support as they were doing currently. The next example is Health Research Incorporated. They are actually a company that deals with funding for grants and research purposes. Funny enough, they originally purchased CloverDX to help them with a migration and to migrate their data from their legacy system to a new system. That's a great use case for us, and they thought that once they're done with that, that they would cancel their subscription and wish us luck in the future. However, once they actually got into the platform, they realized that they could improve their data quality immensely using our data platform. In their environment, they had data issues that were being handled as Java exceptions, and sometimes those were unhandled Java exceptions, unfortunately. But this made it hard for the end users to take a look at the errors, understand what's going on with the errors, let alone being able to fix those errors. Obviously, you would not want business users or non-Java developers even to make changes to code unless they have been trained on it. So whenever they did need to address any issues, they would have to stop one of their Java developers to make changes, which would take them away from their usual functions, right, of adding and improving the platform. Instead, they were spending time fixing errors that popped up. They decided to use the flexibility of CloverDX data management platform to allow them to fix those errors without needing that specialist developer to provide emergency fixes. So with CloverDX, they were able to handle much of the work of managing those errors and kind of reprocessing them on their own. And because CloverDX is designed to handle ever-changing data requirements easily, tweaking the processes became much easier and faster through using the visual designer rather than completely having to rewrite code. They were able to fix some errors completely by adding additional logic and rerouting those and refixing those errors and reprocessing them once they are fixed. Other times they would have efficient ways to work on a queue. That way they could get those alerts and issues to the people that would need to fix them promptly and be able to fix them with ease. That allowed them to reduce the number of errors and actually get their developers back on task of developing and improving their platform instead of just fixing errors that popped up. So hopefully now you guys have a pretty good understanding of what CloverDX Designer or CloverDX Data Management Platform can do and how it can handle the software development lifecycle for your data projects fairly efficiently between not just the different environments, but also between different team members.